Hello Math 152 students. In this video we're going to take a look at the difference between a parameter and a statistic. So we want to take a look at a context for this, try to connect it to some other vocabulary in our chapter. So for this example, we are going to look at a context involving Reese's Pieces. Hopefully you guys will be able to see this as I move my props around here. So let's think about if we were sitting in class together and I handed each of you a scoop of Reese's Pieces that I had scooped out of my bag, like this. And we wanted to ask some questions about our samples. We could say that this sample is like a scoop out of our population. And we might be interested in lots of different things. You might want to know, well, how many are in each scoop? Right? Are all the scoops equal? You might also ask some questions like, hey, it looks like maybe there's fewer brown than any other color. Is that because my sample only had a few brown, or is that because there's fewer brown overall in the bag? So we might start to ask questions about percentages, the percentage of yellow Reese's Pieces or brown Reese's Pieces, and start thinking about what's true about my sample, what's true about my population. These are important concepts for us because we're really going to be working on connecting parameters and statistics throughout the course, and we want to understand how those two terms relate to samples and populations. So when we think about a parameter is a number that describes a population. Now, of course, your population isn't necessarily a single bag. In a different context, you could maybe think about all Reese's Pieces produced from a plant each day and a sample being a bag, right? But in this context, we're thinking about the bag is all that I have, and I'm getting a scoop, and each scoop is my sample. So you really want to clarify what your population is and what your sample is in each context, because it might be a little bit different depending on how you're defining your scenario. So for us, our population is our bag. So if I'm thinking about, let's say, yellow Reese's Pieces, the percentage of yellow in the bag would be a parameter. Whereas if I'm talking about the percentage of yellow Reese's Pieces in my cup, that would be a statistic. So I like to remember the letters go together. It's kind of silly, but it helps me remember it. Population, parameter, and statistic and sample. So for example, let's focus on the sample for just a minute. If I wanted to think about the percent of yellow Reese's Pieces, I could dump my cup, count out my total number, my number of yellow, and calculate that percentage. And then, in turn, if you were sitting at my table, I could ask you to do the same thing for your cup. Would you necessarily think that your percentage is the same as my percentage? Could be, right? It's possible, but then it's also likely that it's not. You might get a scoop that's heavier on yellow, or you might get a scoop that's heavier on orange. So when we think about the term statistic, it's tied to a sample. And for any population, we could have lots of different samples. So our scoops for our samples might generate different statistics. But when we think about the parameter, if I wanted to know the true number of, or the true percent of yellow Reese's Pieces in this bag, I would have to dump the whole bag. So let's consider that scenario for a minute. If I dumped the whole bag and I wanted to figure out the percentage, I would be doing a lot of counting, right? Not necessarily a lot of fun, and it would be very time consuming. But if I asked you to take the exact same bag and do the same procedure, if we can count, you should get the same thing and I should get the same thing. We have an identical bag, I dump it, count, figure out the percentage. You dump the bag, count, figure out the percentage. So if we think about this context, a parameter for any given population is fixed. It doesn't matter if I calculate it or you calculate it, it should be the same. So parameters don't change. They're tied to a population and they're a fixed value. Whereas a statistic, since it's tied to a sample, your scoop or sample might look different than my scoop or sample. So my percentage might be 30% for the sample, but your percentage might be 35% or 40%. So hopefully that clarifies a little bit the difference. You want to be careful because sometimes in everyday language we use the term statistic for just any number, and we're going to be much more particular about it here. we're going to be thinking about, does it relate to a sample or a population? Then, once we have this down pat, we can start to think about connecting the two. So if I'm interested in knowing the percentage in my bag here, it's time consuming to do a calculation involving this, whereas it might be easier to do several samples, look at the percentage of yellow M&Ms, and maybe make some inference or a judgment about the percentage in this bag. All right, guys, so we'll continue to explore this topic as we go through the course.